So you can see, before I show the results of the EVM, I just wanted to show this is the amplifier. That's the PA that I inserted in the template. Taking that PA, simulating it with a linear simulator, it shows linearly, small signal, it has 18.13 dB gain. Using harmonic balance and plotting P in, P out, it shows 18.13 dB gain at the low signal level, and then it starts compressing at around 6 dBm. So at around 6 dBm, I want to measure what is the EVM of this PA. As I said before, I just insert the PA in the template and hit simulate. And these are the results. Notice I have two results, on the left side and the right side. Okay? Why? Because there are two different ways available to simulate and extract the results. One way is to simulate the PA at the transistor level with fully compliant WIMAX source and test bench. It goes through the transistor level and all the component levels design. This is exactly like having your real circuit tested in the lab using test equipments. Okay? By doing this, it's fully compliant. By doing this, the simulation took 20 minutes. And these are the results, 0.846% EVM. And this is the Constellation. But on the right side, I want to mention that there is another way in ADS which uses that technology called Automatic Verification Modeling, AVM, or we call it Fast Co-Simulation technology. Basically what it does, it extracts a behavioral model of the circuit, accurate behavioral model, and runs the WIMAX verification in seconds. Look at this, the same circuit using that AVM technology, and all you have to do is just like check a bubble that says you want to use AVM, just check it to say yes, and hit simulate, and the same simulation took less than 20 seconds to verify the EVM for this PA. Now look at the results. It's very identical. EVM is 0.848 using AVM, and EVM is 0.846. It is extremely accurate, and it is very, very fast to do for verification. Same simulation produces the spectrum, the WIMAX spectrum, and it has that red mask which shows you if you comply with the spec or not. So here it shows that we meet the specification in our amplifier for WIMAX spectrum. Also, I would like to mention that you can also verify your PA to all wireless standards with statistical analysis and process variation. Some people would like to see how is my EVM relative to changing all the parameters to process variation. So what is shown here is an example of how ADS was able to simulate the WIMAX PA with process variations on the lumped elements with 50 Monte Carlo trials in this example. The simulation of these 50 trials took about 10 minutes. And you can see the yield is shown here and the EVM. Also shown on the bottom left side is input power swept analysis for EVM. You can simulate, you can vary the input power and get the EVM for every input power. So the display basically shows the EVM versus input power. Now that we have successfully created a solid design in the schematic page, we are ready to take it to the next level, which is the physical design part. Regularly updated foundry, device, models, and layouts are synchronized in both schematic and layout pages. So with ADS, it is very easy to create physical designs. Either you can do it by auto-generating a layout from the schematic via design synchronization, or by manually placing the layout artwork. Let me explain all this in detail in the next slide. So basically in this part, this is what I will be showing and discussing with you. I'm going to show you the synchronization between schematic and layout in ADS. I want to show how you can simulate a layout in the schematic page. I want to show you the layout and schematic design differences as an LVS check. I want to show you the physical connectivity engine, or what we call LayCon, layout connectivity. I want to show you the DRC tool in ADS, and I want to show you the planar momentum and 3D EMDS tools in ADS. Creating physical designs in ADS is easy. You can auto-generate a layout from the schematic by design synchronization or by manually placing the layout artwork. So you have full flexibility. ADS features 3 different synchronization modes between schematic and layout. This provides you optimum flexibility. You are not constrained by always having the schematic and layout automatically synchronized. But instead, ADS gives you the flexibility to choose from 3 different modes of synchronization. The single representation with no synchronization, the dual representation with half synchronization, and you can choose the always design synchronize between the schematic and the layout. You can even switch back and forth between these 3 different modes while you are laying out the MMIC. This allows you to efficiently and accurately fit designs with many elements into smaller areas. The result is smaller die size and lower overall cost per chip. What is shown on this page is an original circuit schematic that was automatically converted to layout by using the auto-synchronization layout generation in ADS. Now, in this layout format, the design can be immediately used for EM momentum simulation, or, as shown on the top right corner, using the layout look-alike feature, ADS was able to generate a layout look-alike component of the design and simulate it and optimize it on the schematic page. You can even parameterize any of the design elements and change these parameters on the schematic page in order to see the resulting effects in the simulation results. In ADS 2008, a new transparency to layer configuration was added. It allowed designers to set the transparency for easier to see multi-layer designs such as traces, grounds, and vias. So this is just an illustration how before it used to be with different layers and colors, and now after you can set the transparency and how transparent you like any layer to be. What is shown on this slide is a new design differences window that identifies components in the layout but are not in the schematic, or components in the schematic but are not in the layout. It also shows the parameter differences and the nodal mismatches, all displayed on an open window here. So it acts like an LVS, and it detects and tells you what is missing in the layout or the schematic so you can fix it. So what is shown here is a window that tells you all this information. Now this window here shows a custom LVS utility program that can be loaded in ADS in seconds.